Dragon's Gambit. Strategic Intelligence Analysis, Episode 1. Part 2. China's Leverage Weapons, the Tools That Make Adversaries Hesitate. Rare Earths, AI, Manufacturing Dominance, and the Instruments of Economic Coercion. Rare Earths, the Periodic Table as Geopolitical Weapon. In July 2023, China imposed export controls on gallium and germanium, two metals essential for semiconductors, fiber optics, and night vision equipment. In December 2023, it added graphite, critical for EV batteries. In April 2025, it restricted 7 categories of rare earth elements and magnets in direct response to U.S. semiconductor export controls. This is not coincidence. This is the systematic deployment of a resource advantage as a geopolitical tool. China controls approximately 70% of global rare earth mining and, more critically, 85 to 90% of global rare earth processing capacity. The distinction matters because the processing technology, the chemical separation, the purification, the conversion into usable materials, is where the genuine choke point lies. Even nations with their own rare earth deposits, the United States, Australia, Canada, depend on Chinese processing for the finished materials their defense and technology industries require. The 17 rare earth elements, plus strategically critical materials like cobalt, lithium, and graphite, underpin defense systems. F-35 fighter jets require approximately 920 pounds of rare earth materials each. Tomahawk cruise missiles, Virginia-class submarines, and precision guidance systems all have critical rare earth dependencies. Electric vehicles, each EV battery pack requires significant quantities of lithium, cobalt, and graphite, the majority of which flows through Chinese processing. Semiconductors, gallium arsenide and gallium nitride are essential for high-frequency chips used in radar, communications, and power electronics. Renewable energy, wind turbine permanent magnets rely heavily on neodymium and dysprosium, both Chinese processed. The strategic implication is direct. In any scenario where China chooses to weaponize its resource position, whether over Taiwan, trade disputes, or broader geopolitical confrontation, it has the ability to impose costs on American and allied defense production that cannot be resolved quickly regardless of how much money is allocated to alternatives. The United States has made significant investments in alternative supply chains since 2020. The Mountain Pass mine in California resumed rare earth processing. Australia's Lynas Rare Earths has expanded. The MP Materials deal with the Department of Defense has moved processing toward American soil. But the timeline for genuine independence from Chinese rare earth processing remains measured in years to decades, not months. Artificial intelligence, the race that determines everything else. The competition between the United States and China in artificial intelligence is not simply a technology race. It is the meta-competition that will determine the outcome of every other competition, military, economic, diplomatic, and informational, over the following decades. Here is where the picture is genuinely complex, and where Western commentary most frequently errs in both directions. China's documented AI capabilities in 2026. DeepSeek's R1 model, released in January 2025, demonstrated performance comparable to leading American models on multiple benchmarks, at a fraction of the training cost, using chips that were not the most advanced available. This was not a theoretical result. It was a demonstrated engineering achievement that shook the assumption that American chip export controls would create an insurmountable technological gap. China leads the world in AI patent applications by volume, approximately 38,000 AI patents in 2023 compared to approximately 6,300 for the United States. The relevance of patent volume is contested. Quantity does not equal quality, but the trajectory indicates the scale of Chinese investment in applied AI research. In specific domains, China's AI capabilities are genuinely world-leading. Computer vision and surveillance. China's facial recognition systems, deployed across its domestic surveillance infrastructure, represent the world's most extensive real-world deployment of computer vision AI. Industrial AI, automation, quality control, and logistics optimization in Chinese manufacturing. Autonomous systems, drone swarm technology, unmanned surface vessels, and autonomous ground vehicles with military applications. Synthetic media and information operations, AI-generated content capabilities that present significant challenges for information environment integrity. China's documented AI constraints. The fundamental constraint is semiconductor access. Training frontier AI models at the scale of GPT-4 or its successors requires massive computational clusters of cutting-edge chips. NVIDIA's A100 and H100, and their successors, are subject to U.S. export controls that have been progressively tightened. China's domestic chip industry, led by SMIC and Huawei's HiSilicon, has achieved genuine progress. Huawei's 7nm Kirin 9000S chip demonstrated in 2023, but remains 1 to 2 generations behind the leading edge. The result is a genuine choke point that constrains China's ability to train the next generation of frontier models at full scale. DeepSeek's efficiency achievement is, in part, a response to this constraint, necessity driving innovation in training efficiency. But efficiency optimization cannot fully substitute for raw computational capability at the frontier. The honest assessment: China is a Tier 1 AI power with genuine capabilities and serious constraints. The gap between Chinese and American frontier AI is real but narrowing, and the direction of travel depends heavily on whether export controls hold and whether American companies maintain their leading-edge advantage. Manufacturing supremacy, the factory floor as strategic asset. China's dominance in manufacturing is not simply a legacy of cheap labor, a characterization that was always incomplete and is now simply wrong as Chinese wages have risen substantially. Chinese manufacturing dominance in 2026 rests on 3 structural foundations. First, supply chain density. In almost any industrial sector, the full supply chain, raw materials, intermediate components, specialized tooling, logistics, assembly, quality control, workforce, exists within China at a density and cost structure that no alternative location can replicate quickly. Moving production out of China does not mean replicating the Chinese supply chain elsewhere, it means building new supply chains largely from scratch, with different cost structures, different logistics, and different risk profiles. Second, scale economies. China's domestic market is large enough to support production volumes that create cost curves unavailable to producers serving smaller markets. In electric vehicles, solar panels, and batteries, Chinese producers have moved so far down the cost curve that competitors in other markets face structural disadvantages that are not resolvable through tariff protection alone. They require equivalent scale, which takes time and sustained investment to build. Third, policy alignment. The Chinese state has demonstrated the capacity to direct industrial investment at a scale and speed that market-based economies cannot match for specific strategic priorities. The EV sector, solar energy, and battery manufacturing have all received levels of state support, subsidies, preferential financing, land allocation, grid priority, that amount to industrial policy at a scale unprecedented outside wartime mobilization. The result: China produces approximately 57% of the world's steel, 53% of its aluminum, 85% of the world's solar panels, 60% of its EV batteries, and 80% of the active pharmaceutical ingredients used globally. In each of these sectors, the dependency is structural rather than incidental.